there is only one repeated number in the nums. So this is the hint: 1, 2, 3, 4, 5, 4, 4. So the numbers are like jumbled within the array. You must solve the problem without modifying the array nums and use only constant extra space. Okay, so this is a very tricky part because you need to use only constant space and you cannot modify. There's a lot of ways to solve this if you think about it, because like normally most of the solution requires extra space to track the numbers where it's duplicated. But there's a way to solve this tracking. Another way of doing this, you can sort it, then you can find the duplicate, right? But again, you cannot modify array nums. So how do we solve this? There's an algorithm called Floyd's algorithm, which allows you to do the tortoise and hare pattern. Notice that this will only works of a 1 to n inclusive. Like for this case, because 1, 3, 2, 2, yeah. And you can position the value as the index of the array. If you think about it, because this typically when you sort this 1, 2, 3, 4, and there's a duplicate of 2, right? In a typical scenario where you could just basically point the pointer of your index through the values. Like for example, for index 1, for index 0, is 1. So you know that 1 should be in the position 1. So you could just go to position 1, right? And then in position 1, there's value 3. You can just go to position 3. Position 3 is 2. Then from 2, it goes to 4. 4 goes to 2. Then you know there's a duplicate. You do meet 2 times. So this is more like trying to find out the cyclic thing in a linked list. You know that you can chain the linked list, and then if it's cyclic, you will pass through it 2 times. So for this example, I could show you this 1, 3, 2, 4. So if I map this, if I just try to map using jumping through this index per position to that position, you'll find something like this. So 1, 3, 2, 4. You know that 2 and 4 goes back to each other. So once you map out something like this, things gets much easier. You know that it's like a linked list, right? So again, this only works if your array is 1 to n inclusive and they're mapping in, there's only one repeated number. They're like trying to map that in the index of the array. It doesn't work if you have more than one duplicates, for sure. So yeah, so we have mapped this to something like this. So if I go to index 1, the next index that I need to go to is 3, the next index 3 is 2, the next 2 is 4, and 4 goes back to 2. So notice that in order for you to find a duplicate in a linked list, you can simply just use 2 pointer. One is the turtle, which is the pointer moves only 1 index, and the hare, which moves 2 index. So initially you start at 1, bought the turtle and the hare, the index 1. So the turtle moves 1 index here to 3, and the hare moves 2 index. So that's why the hare is now in position 2. Now if you move 2 index, for the hare, it goes back to position 2. If you move the turtle to 1 position forward, now they're on the same position. So that's why you get something like this. Now you know that there's a cyclic because they made up with each other after you run using the moving 2 steps and 1 step forward. Now how do you find then? So from here, there's a pattern wherein you could just reset the turtle back here. And then if you notice that if you move 1 step forward, 2 step forward, the hare, when you move the hare also 1 step forward, they will meet up with the same position. So for example, it's like this one, right? So 1, 3, 2, 4. And the next iteration, I move this turtle here to 3. And then this one becomes the hare. You move the hare 1 position also forward, right? And then eventually you move one position forward, it becomes 2, and then 3 moves 2. So now you found the duplicate, which is the position where it started having the cyclic, which is 2. So you can't just simply, for this example, it's the same position, right? The 2 is the same position as so that's why you need another loop here that allows you to find the starting position. A much bigger example would be something like this. I'm gonna give you one more example, which is a bigger example. So here they started with 2, right? And then the hare moves 2 spaces forward, the turtle moves 1 space forward. Same as here, 1, 3, 5, 8, and then here 8 move 2 step, 9, it's 3, then you move 2 step, 5, 6, then 6, and then 8, and then you move 2 steps, 7, and then move 1 step, 7. So now you find that the cyclic, there's a cyclic, but this is not necessarily the starting position where they meet. In order if you meet to find the position where they meet, you need to have another loop that moves the hare and turtle one position. Now this is like when you move one position, they're gonna meet each other. So for example, so we set the turtle to 2, here 7, so you move one position, so you got here, and then 7 move one position, then now here. So this is now your result. So this is the second loop here. Yep. So in this example, the answer is not 7, so you have to do another loop which allows you to move the turtle in here forward. So this is a very common pattern when you're especially doing the linked lists, you're trying to find where they meet at the intersection. You can look it up, Floyd's algorithm. So how do we write the code for this? So yeah, so this is the first loop. First we gotta focus first on the first loop, right? So first we have to have 2 variables here. This is here, which is the faster one. Bottom is starting at the position turtle. Nums 0. So we're gonna put a loop here for here. It's not. Oh no, we just put a loop. So what is here? Here is you move two times. So nums here, and then the turtle you move 1 time. So nums turtle. So basically you're just assigning the position of the value to that position that you loop it through. So what's your execution? If here is equal to turtle, then you basically get out, basically break out of the loop. So we found, that there's a cyclic. So we now go for the second loop, which is the one that we're talking about. The second loop is for here is not equal to turtle, and here moves 1 position forward. Now we need to move 1 position forward, not 2 position, and then turtle nums turtle. While they're not equal, once they are equal, then you know that their position is the matching one, which is the here, which is the return here. So let's try it out. This one should be nums. Okay, case 3 is original position. Okay, there you go. Okay, there you go. So this is how you solve this problem. So if you like this video, please hit like and subscribe, and we'll see you again in the next episode of LeetCoding. Thank you for watching.